Hi there, this is 3-7, Solving Systems of Equations Using Kramers Rule. And this is a video for Algebra 2. And so before we get started, like it says, we are going to be solving systems of equations. And we did that at the beginning, 3.1 through 3.4 or so. And then we learned about matrices and how we could multiply those, add those, and whatnot. And so now we're going to be applying what we know about matrices to systems of equations, and in the hopes of being able to find some easier techniques for solving systems of equations. You will recall that elimination was a long process. Substitution, especially when you had 3 variables, was a really long process. So hopefully this will help us speed it along a little bit. So before we get started, we have to understand a determinant. And a determinant is just that. It basically determines whether or not an inverse exists. And we'll be dealing with inverses again in the next section. But in order to get started, we kind of have to know what a determinant is. So there are 2 types of determinants that we'll be using in this lesson. The first is a second order determinant. And basically that means it's the determinant of a 2x2 matrix, which is why it's called second order. The other one that we'll be dealing with is a 3x3, and we'll be calling that a third order determinant. Okay, so there's 2 ways that you can use notation for a determinant. One is to write the words or the letters D, E, T in front. So this is determinant of matrix A, B, C, D. Another way, and this is the one that sometimes catches people off guard, is these bars kind of look like absolute value bars, but rest assured that when we're dealing with matrices, context is really important. And in this case, these are not absolute value bars, they're determinant bars. So when you see those bars, like you see here in the do-it-yourself example, where it just has the bar, you might ask, well, what am I supposed to do? Do you take the absolute value of all the numbers? No. It's asking you to find the determinant. Okay, and so then what the actual determinant is basically the product, well, the difference you subtract. So you see the difference here. Subtract the 2 diagonals. So you've got A times D is one diagonal, and B times C, it kind of reminds you of a cross product in a way. So you multiply A times D, multiply B times C, and then subtract the 2 products from each other. So you get this equation, AD minus BC. So we're going to do that now with this example here. So we're going to go ahead and do our first diagonal. And so 5 times 9 is 45. So if I want to show all my work, I'll do 5 times 9 minus -4 times 8. Okay, so here's a minus. And then we have 8 times 4 is 32. It's -32. So that means that I'm going to take 45 and actually add 32 because it's minus negative. So then my determinant will actually be 77. So it's important to note that when you are calculating a determinant, the answer will be one number, a scalar. When you multiply 2 matrices, the answer is another matrix. But when you are evaluating a determinant, the answer will just be one number, in this case 77. So we'll try that one more time in part B. So we're going to do 0 times -11 and subtract 6 times 4. And so 0 times anything is 0, and 6 times 4 is 24, so we get 0 minus 24. So this time my determinant is -24. And that is basically how you find a second order determinant. So now I'm going to leave you to do it yourself number 1, and then we will go on to our next example. And that is going to be a little bit more of a process here. So first off, I'm going to make some space here. And you'll see why in a second. But let's see here, pink. Okay, so now we're going to talk about a third order determinant, and it's not as simple as the second order determinant, but I put here some steps for you in case you need to go back and remember what the steps were. But I do think that it's a lot easier just to kind of follow the example, and then maybe the steps will make more sense. When you read the steps at first, it can kind of sound confusing. So the first thing you want to do is rewrite the first two columns. That part's easy. So you want to take the first two columns of the matrix. Notice how it has the bars again. So they want me to find the determinant here. So I need to take these first two columns. Remember, columns go up and down. And I want to rewrite them. So I'm going to rewrite 4, -3, -4, and then -8, 2, and 5. And now you'll see why I moved the word using over here so that I can have space to do that. That's the first thing you want to do. Then it says in step 2 to draw diagonals. And you do want to do the diagonals in a specific order. So we're going to start from the top left, and then you're going to draw diagonals like this. So you'll have 3 numbers in each diagonal. And this is why you have to repeat that column. So you can have 3 numbers on that diagonal. And then you have 3 numbers on that diagonal. Okay? So that's the next thing you're going to do. So draw diagonals. And then you want to multiply the elements in each diagonal. I want to multiply 4 times 2 times 9. So I'm going to put down over here 4 times 2 times 9. And then it says to repeat the process. I'm also going to take -8 times 6 times -4. And I'm going to take 3 times -3 times 5. So I'm taking each diagonal has 3 values. So -8, 6, -4. So -8, 6, -4. My third diagonal has 3, -3, and 5. So 3, -3, and 5. And I want to multiply those. Then it says to repeat the process. I didn't want to get too technical with how I mentioned that. So when it says to repeat the process, what that means is that I now have to draw more diagonals, only this time I'm going to be going in a backwards direction, so to speak. So now I'm going to pick a different color, and now we're going to go, instead of starting from the top right, we're now going to go to the bottom, sorry, top left. We're now going to go from the bottom left, and we're going to go this direction. So now you want to follow the red arrows. And it can get kind of crazy if you're not paying attention. So now we're going to do -4 times 2 times 3. So you've got your -4, your 2, your 3. Then I need 5, 6, and 4. So 5, 6, and 4. And lastly, 9, -3, and -8. 9, -3, and -8. All right? So that's kind of what it meant by repeat the process. So you want to do the diagonals again, only this time starting from the bottom left and going upward, and the first time starting from the top left and going downward. Okay? Then it wants us to find the sum of the products for each set of diagonals. So they want, and there's 2 ways to do this, okay? Basically, you want to add these all up together. So you can, and then subtract. So the last step is to subtract the second sum from the first. So what I've done is I've basically subtracted all of the red ones. So all the arrows that are going up are being subtracted, while all the ones that are going down are being added. But you can see that what they're asking you to do is to just subtract once. So you can do it either way. And so the first step we have to do is find all those products. So 4 times 2 is 8. And 8 times 9 is 72. And then -8 times +6 is -48. And -48 times -4 is 192. And then 3 times -3 is -9. And -9 times 5 is -45. And then over here we're going to do -4 times 2, which is 8, so that's -8, sorry. And then -8 times 3 is -24. And then 5 times 6 is 30, and 30 times 4 is 120. and 9 times negative 3 is negative 27, and negative 27 times negative 8 is going to be 216. Okay, so to show you what I mean about the two different methods, the step number 3 says to find the sum of the products for each set of diagonals. So what they want us to do is to add them up. So we want to go 72 plus 192 plus negative 45. That brings me to 219. And then if I take the sum of negative 24 plus 120 plus 216, I get 312. Then it says in step 4 to subtract the second from the first. So now I want to go 219 minus 312. And so my final answer is negative 93. Okay? However, you can also get that same value by taking, and what I've done is all the black arrows were pluses. This is a positive, plus, and a plus here. And then all of the red arrows had a minus in front. This is minus negative 24. This is minus 120, minus 216. So instead of doing it the other way, I could just take 72 plus 192 minus 45 minus negative 24 minus 120 and minus 216, and I would still get the same negative 93 answer. So you can choose to do whichever way you want as far as, I just think it's easier to put the plus, 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 minus, minus, minus. But if you don't want to do it that way, you can do it the other way. So that's how you do a third order determinant. So now we'll have you try these two on your own. And then we have another application that you can use determinants for, and that is to find the area of a triangle. So here what we have is that if you are given the vertices of a triangle that are A, B, C, D, and E, F, so it doesn't really matter which one you pick, but you can pick A, B, C, D, E, F, then the area, so the determinant or the area of the triangle is the absolute value of A, because obviously area has to be positive. So in this case, these actual bars are absolute value. You do want the number, like you know how in the previous example we got negative 93. That obviously wouldn't work for area. You want the number to be positive. So you want the absolute value of the area, but the equation is this guy right here. So basically this is a determinant, a third order determinant, and then you take that result and times it by a half, and that'll give you the area. If that number happens to be negative, then you have to remember to make it positive. So in example 3, it's asking us to find the area of the triangle. So we're going to do that. And one of the first things you want to do is identify what A, B, C, D, E, and F are. And then we're going to set up our matrix. So I'm going to put A and B, so you'll see A, B, 1, so we're going to have a 1/2 out here. And we're going to have A is negative 2, B is 8, and then we always have a 1. That's part of the formula. And then we're going to do CD1, so we're going to do CD1, and EF1, 0, 0, 1. But like we learned before, the first thing I want to do is to rewrite the first two columns, so negative 2, 4, 0, 8, 12, 0. Then we want to do our arrows going this direction. Okay, so I'm going to come over here where I have more space. So I've got negative 2 times 12 times 1. And then I've got 8 times 1 times 0. And then I've got 1 times 4 times 0. So all of the blue diagonals are going in the downward direction here. And so I am going to now go upwards. And remember, the way that I do it is to just make these all minuses. So now I'm going to go, these are all pluses, and I'm going to go minus 0 times, oops, that's where you start making mistakes. This is 0 times 12 times, when I put a 2 there, 0 times 12 times 1 minus 0 times 1 times negative 2 and minus 1 times 4 times 8. 1 times 4 times 8, 0, 1, negative 2, 0, 12. Okay, so now I can come over here and say 12 times negative 2 is negative 24, and 0 times anything is 0, and 0 times anything is 0 there as well. And here's another 0, so that's 0, and that's 0. And then lastly, 8 times 4 is 32. So that becomes a 32. So now all I really have is the negative 24, and then plus 0, minus 0, minus 0, and then minus 32. So then the answer would be negative 56, and then divided by 2. So you have here times a half. So you want to divide that by 2, which would be negative 28. But because it's the absolute value of that, you would get 28. So the area of this specific triangle would be 28 square inches. So that is how you get the area of a triangle using the determinant. So now we'll have you try this guy. Now this is actually an example in the book. It's talking about raising money. So it says to raise money for their rowing club, Hannah, Christina, and Dario are advertising a car wash at 3 different street corners in a neighborhood. On a map, the coordinates for the corners, and that's all I wrote on the board, is 315, 64, and 11.9. Each unit represents 0.5 kilometers. What is the area of the neighborhood in which they are advertising? So basically there's 3 people, they have 3 different street corners, and these are the vertices of those street corners, and you're trying to figure out the area of where they're advertising. Keeping in mind that when you get your answer, each unit represents 0.5 kilometers, so you'll have to take that into account as well. All right, so now, after all that, we finally get to the good stuff, which is actually what this lesson was about, which is Kramers Rule. So Kramer was a mathematician, and he came up with this process. So of course, it's rightfully that he gets to basically take credit for the method. So it's called Kramers Rule. All right, and so Kramers Rule likes to use a bunch of determinants in order to solve. So that's why we had to show you what a determinant was before you could actually use Kramers Rule. So the first thing I wanted to look at is the system. We can remember what this looked like before, where you had 2 equations, 2 variables, x and y. And this is kind of what it looked like. A and b are just the coefficients of x and y, and m and n are the constants. Okay, so then what we have is the coefficient matrix. The coefficient matrix is basically when you just take the coefficients of x and y for the system. So there's no m and n, there's no constants over there, just the coefficients of x, which are in blue, and the coefficients of y, which are in red. So that's what your coefficient matrix looks like. Based on that, we have 3 separate determinants. You have your just standard determinant, what we call the d sub x determinant, and the d sub y determinant. So what you have here is that in the generic determinant, just the standard one, just the regular d, all you do is you basically take the determinant of the coefficient matrix. So it's the same elements as the coefficient matrix, but of course we're using the bars here, which mean that you actually have to evaluate the determinant of just the coefficients, so just the x and y coefficients. The d sub x determinant is where you replace the column, which is the x coefficients, and replace it with the constants, which are m and n. So you replace this column, which used to be x, with mn, and then you have your b and your d, which are your y. So you have the constants and the y coefficients. And the dy is the reverse of that. So you leave the x, and then you replace the y coefficients with the constant column. So, and then calculate its determinant. So if you do all that, then the solution of the system is going to be, for the x coordinate, you're going to get dx divided by d, and for y, you're going to get dy divided by d, or you can put it in our normal form. When we solve a system, we always put it as an ordered pair, so that's just the ordered pair form. So I want to show you now how that works. So here we go. Solve the system by using Kramers Rule. So we need a bunch of determinants. So the first thing I'm going to do is get my determinants maybe over here. The first one is going to be the coefficients. So 5, 3, -6, 4. My dx is going to be for me to replace the x with the constants 15, -29, and leave the y alone, -6, 4. My dy is going to be the reverse of that, so I will replace the x with 15, I will leave the x, which was 5 and 3, and replace the y column with the constants, which is 15, -29. Okay, so that's the first thing you have to do, is find all of your different determinants, okay? Okay, so now let's calculate them. So we did this earlier. You want to go 5 times 4 minus -6 times 3. Over here I'm going to go 15 times 4 minus -6 times -29. And over here I'm going to go 5 times -29 minus 15 times 3. Okay, and then we have to simplify all that. So 5 times 4 is 20. -6 times 3 is -18. Over here, 15 times 4 is 60. And a -6 times a -29 is going to be a positive 174. And then 5 times -29 is -145. And 15 times 3 is positive 45. So now we're going to get 20 minus -18. So be careful with it's a minus -18. Which is now going to give us 38. Then we have 60 minus 174. That'll give us -114. And then we're going to do -145 minus 45 and get -190. So according to our thing earlier, x is going to equal, and that's right here, x is going to be dx over d, and y is going to be dy over d. So I just want to remind you, so x is going to be dx, and dx is right here. So we're going to get -114 divided by d, which is 38. And our y value is going to be dy, which is -190 divided by d, which is 38. And we want to reduce those fractions, so -114 divided by 38 is actually -3. And -190 divided by 38 is -5. So when we write our final answer, we put the x first and the y second, and this would be our solution to our system. And I think that it's a lot easier that way than it was to do elimination from before. So -3, -5 is our solution. And that is how you use Kramers Rule. So we're going to allow you to try these on your own, and then we're going to do one last example. And our last example is the exact same thing. No need to try to recreate the wheel. We have the same pattern going on here, but now you'll really appreciate Kramers Rule, because I know that a 3x3 was really a long process. So now we can use Kramers Rule, we can apply it to this as well. So the first thing we need to get is our determinants. So just like before. This just means that you have to do it an extra time. So now you're going to have a d, a dx, a dy, and a dz. And you'll realize that in the past, all we did was take, like for the dx, we took the x column and replaced it with the constants. So in the y, we took the y column and replaced it with the constants. And so when you can imagine it in the z, you're going to take the z column and replace it with the constants. So it's the same concept, just a little bit larger. And of course, calculating a third order determinant is a little bit more doozy than calculating a 2 or a second order determinant. But here we go. So for d, you're going to get just the coefficients. 4, 3, 7, 5, negative 2, negative 6, negative 6, 7, and negative 8. So 4, 3, 7, 5, negative 2, negative 6, negative 6, 7, negative 8. Just making sure. And for your dx, we are going to replace the x column with the constants, which are negative 14, 47, and 15. And then everything else stays the same. The y and the z columns stay the same. So we're going to do 5, negative 2, negative 6, and negative 6, 7, negative 8, like that. And then, before I go on to the next ones, I need to make sure I have enough space. So I'm going to go ahead and do this determinant. We're going to, remember, rewrite the first 3 columns. Sorry, the first 2 columns. Like that. We're going to do our arrows. Wrong color there. So we're going to go 4 times negative 2 times 8. We're going to then do 5 times 7 times 7, and then negative 6 times 3 times negative 6, and then we're going to go upwards. So I'm going to go minus 7 times negative 2 times negative 6, minus negative 6 times 7 times 4, and minus 8 times 3 times 5. It's very important that you make sure that you have all your numbers right. 4, negative 2, see, I've already seen a spotted error there. This is a negative 8, so you want to make sure I put my negative in there. So 4, negative 2, negative 8, 5, 7, 7, negative 6, 3, negative 6. And then for the red ones, we've got a 7, negative 2, negative 6, negative 6, 7, 4, and a negative 8. This should be negative 8, 3, and 5. So now to calculate, we're going to go 4 times negative 2 times negative 8. This is 64. 5 times 7 times 7 is 245. Negative 6 times 3 times negative 6 is 108. So then we're going to do 7 times negative 2 times negative 6 is 84. All right, and then we're going to do negative 6 times 7 times 4 is negative 168. And negative 8 times 3 times 5 is negative 120. So our answer is going to be 64 plus 245 plus 108 minus 84 minus negative 168 minus negative 120. And you get 621. Okay? So that's going to be our